What is the area of the red region? Given that O is the center of the circle. Area of a sector of a circle, right triangle, and Pythagoras' theorem are used to solve this question. Solution. Label points C, D, E, and G. Let R be the radius of the circle. Since length OE equals R, this implies that length OG equals length OE minus length EG, which equals to R minus 7. Also, length CG equals 13 and length OC equals R. Using Pythagoras' theorem, the square of length CG equals the sum of the square of length OG and the square of length CG. Substitute values. We have that the square of 13 equals the sum of the square of R minus 7 and the square of R. Expand bracket. Also, simplify terms. It follows that 169 equals the square of R minus 14 times R plus 49 plus the square of R. Combine like terms and simplify. So that 2 times the square R minus 14 times R minus 120 equals 0. Divide out by 2. This implies that the square of R minus 7 times R minus 60 equals 0. Factorize. We have that the square of R minus 12 times R plus 5 times R minus 60 equals 0. Factorize further as shown on the screen. Then write as a product of two factors. This means that the product of R minus 12 and R plus 5 equals 0. Therefore, either R plus 5 equals 0, or R minus 12 equals 0. Make R the subject of the formula in the both equations. We have that R equals negative 5. Or R equals 12. Hence, R equals 12. And R is not equals to negative 5. It is because no negative value exists for length measuration. Hence, area of red region equals area of quarter circle COD minus area of right triangle COG, which equals 1/4 of pi times the square of R minus half the product of length OC and length OG. Substitute values. Therefore, area of red region equals 36 times pi minus 30, all in square centimeters, which equals to 6 times, in bracket, 6 times pi minus 5, all in square centimeters.